Here we are on a brand new Jupyter notebook ready to get started with coding our first Python program. The name of the notebook here is Using Python as a Calculator, and what we're going to see is at its heart, a programming language is also a calculator which performs calculations or computations. It, of course, can perform far more complex computations than an ordinary calculator can. We spoke earlier about hitting Shift Enter to create new code cells where you can write and execute commands. You can also use this plus button here in this Jupyter Notebook menu in order to create code cells, and that's what I'm going to do here. Click on plus multiple times and a new code cell will be created each time. These are the code cells where we'll write our Python code. Before that, let's confirm the Python version that we're using. We saw earlier that you can run shell commands or command prompt commands from within your Jupyter notebook. Make sure that you precede this command using an exclamation point. You can see the current version of Python is 3.7.1. The way you execute any command within a code cell is by hitting Shift Enter. Let's type in some simple Python code. I want to calculate 7 plus 9. So I simply type in 7 plus 9 and notice that when I hit Shift Enter, I get the output here right on screen within my browser window. The result is 16. Even though you aren't using any Python specific commands, what you've actually executed is a bit of Python code. When you hit Shift Enter, the notebook computed the result of this plus operation and displayed the result within your browser window. Let's try this once again. 20 plus 47, hit Shift Enter, the result is 67. So far we've used just integers. We haven't worked with decimals or floating point values yet. You can include floating point values in your calculations as well, such as 27.5 plus 9.4 plus 2. Floating point values such as decimals as well as integer values are together referred to as numeric values. Shift Enter will give you the result of this addition, which is 38.9. It's not just addition operations that are supported by Python. Python supports subtraction as well as division, multiplication, and so on. 17 minus 10 will give you 7. Now that you've understood how to apply arithmetic operations within Python, you can try this with a number of different examples. Here is an example of subtraction once again. This time we've used floating point numbers and that works as expected. Now you might say that 23.6 minus 13.6 is actually just 10 and you'd be right. With floating point numbers, the precision might be a little off. So this number, the result here is very close to 10, not 10 exactly. This is true of all programming languages, not just Python. Very high precision might be a little tricky. If you can perform simple addition and subtraction, it stands to reason that you can combine these operations as well. Here is a combination of plus as well as minus to give you a result. Obviously, these arithmetic operations will follow the BODMAS rule that we learned back in middle school. Brackets will be evaluated first, then division and multiplication, and then addition and subtraction. Here is an example of how you would perform a multiplication operation in Python. Notice that we don't have a multiplication symbol on our keyboard, which is why we use the asterisk for multiplication. 2 multiplied by 6 gives us 12. Once again, you can mix integer values with floating points to perform your arithmetic operation. 10 multiplied by 5.5 will give us 55. Observe that the 55 is actually 55.0. So each time you have a floating point involved in your computation, the result of that computation will always be a floating point value. If you have multiplication as well as addition operations, multiplication will be performed first based on the BODMAS rule. So 2 multiplied by 3 multiplied by 1 gives us 6 plus 2 gives us 8. And the result displayed here below your code cell is 8. Just like with ordinary math, if you want certain computations or operations to be performed first, you'll include them within brackets. So 1 plus 2 will be computed first. That will give us the result 3. Python will perform that computation before it performs the rest of the multiplication. So 2 multiplied by 3 gives us 18, and that is indeed the result. You can also perform power of operations in Python. And the way you indicate this is by using the double asterisk sign. This is 10 to the power of 2, which gives us 100. Let's try this once again so that you get familiar with it. 2 to the power 4, which is indicated by the double asterisk sign, will give us 16. In the case of addition, subtraction, multiplication, and power of operations, if you specify only integers in the computation, the result will be an integer. If you specify a floating point, the result will be a floating point value. Division operations can be performed using the forward slash. Here the forward slash indicates that we want to divide 10 by 5. 10 is the numerator, 5 is the denominator. Observe that the result here is 2.0. In the case of the division operator, even though both of our input numbers are integers, the result is a floating point. If you're only interested in the integral result of the division, you can specify a different kind of operator, and that is the double forward slash. The double forward slash tells Python is that we're only interested in the quotient of the result. Remember, the result of a division is a quotient and a remainder. When we use the double forward slash, Python will only calculate the integral portion of the result, that is the quotient, and the result here is 2. The difference between the double forward slash and the forward slash is more obvious when you perform a division operation such as 10.5 double forward slash 3. Now you know from basic mathematics that the result here will be a floating point value, but we are interested only in the integer value of the result, which is 3. The double forward slash has calculated just the quotient of the result. It has entirely ignored the fractional part or the remainder. And that is why the result here is 3 rather than 3.5. And as you might imagine, just like you can calculate the quotient, you can also ask Python to give you the remainder of a division operation. And this you do by using the percent operation, also referred to as the modulo operator. So 50% 4 here will divide 50 by 4 and give you the remainder as a result, which is 2. Once you start programming a lot more, you'll find that this modulo operation is very useful for various numeric computations. Let's try the modulo operation once again. This time we'll divide 50 by 5. This is an even division. There is no remainder, and that is why the result here is 0. The remainder is 0. Now that you have some basic practice using Python as a calculator, you can perform more complex operations. Include the operations that you want performed first in brackets. Remember, the BODMAS rule has been followed in every case. Here, 4 plus 7 will be computed first. We get the result 11. The result 11 will then be multiplied by 2, will give you 22. And you divide 22 by 4 to get the result. 22 divided by 4 will give you 5.5, and this 5.5 you will subtract from 40.5 to give you the result 35. This is just a simple explanation of the BODMAS rule, but it's important that you understand that Python works this way. Here is another computation, but notice that there are outer brackets around the numerator. So the entire numerator will be calculated first, and then the result of that will be divided by 5. This is something that you can verify on your own and see if you get the result 37. Now it turns out that you can perform the multiplication operation where a string is involved as well. Here the string is hello Oliver, which is just a sequence of characters and which is enclosed in quotes, double quotes. In Python, you can use both the single quotes as well as the double quotes to enclose a string. Here you multiplied the string hello Oliver by a number 3. What does this mean? Python basically interprets this to mean hello Oliver 3 times. The result of this multiplication operation is this string concatenated 3 times, and the result is also a string. The multiplication operation is the only one that works with strings. If you try hello Oliver plus 3, this is not supported, and Python will display an error as you can see on screen. This error here can only concatenate str, not int to str, means that the plus operation can be used with 2 strings and it will simply concatenate those strings together. It cannot be used with a string and an integer.